What is the interval convergence of the power series? Summation, okay, 1 to infinity, x minus 4 to the n over the square root of n times 2 to the n. Okay. So we kind of have two things going on here. It looks like we have a geometric series and we have a 1 over square root of n. So the idea here is what values of x can we put in there to make this converge? So to make it a little bit clearer, I will rewrite it as n equals 1, infinity, 1 over 1 over n to the 1/2 times x minus 4 over 2 to the quantity n. Okay, so this makes it reasonably clear that we have a geometric series right here, which we can solve. Totally fine. And then we have something that's like a, not like a power. So this makes you think of like the harmonic series. So harmonic series is summation of 1 over n. It does not converge. 1 over n to the first. But if you have 1 over n to anything less than 1, like 1/2, everything along this way will diverge. But if you have a power greater than 1, 1 n to the 1.1, oh, that was terrible. But you know what I mean. 1 to the n squared, these will all converge as the power gets bigger. So 1 over n cubed, 1 over n to the 6th, etc. And the way you can prove that is through the integral test. You don't have to prove it here, but the idea with the integral test is a series can be thought of as a bunch of Riemann sums. Riemann sums can be thought of as an approximation for an integral. Therefore, if the integral converges, the series will also converge. So that's one of the ways you can see that the harmonic series is 1 over n, series forever, does not converge. Diverges, in fact. Okay, so now we have the geometric series. So the geometric series is something that's kind of like of the form n equals 0 to infinity of r, I'd say it goes to k, of n, and that we know goes to 1 minus r to the k plus 1 all over 1 minus r. So the trick we're going to have here then is r has to be less than 1. Because if it's 1, then it'll stay 1 forever, because 1 to whatever power will always be 1. Anything greater than 1, like 1.2, 1.6, 20, whenever you start taking powers to it, 1.1 squared, 1.1 to the 5th, 1.1 to the 9th, it'll keep getting bigger. And you'll get this exponential growth type thing, geometric growth. But if you have it, r is less than 1, like 1/2, so you start with 1/2, and then you square that, you get 1/4, square that, you get, okay, cubed. 1/2 cubed would be 1/8, 1/16, 1/32, and it keeps getting smaller. So a geometric series only converges if this value in the middle is less than 1. So what we're going to do here is find where x minus 4 over 2 is less than 1. So x minus 4 is less than 2. X is less than 6. One other thing is it can be x minus 4 over 2 can be greater than negative 1, because you can have negative 1 squared, etc., etc., etc. So this would imply then that x minus 4 is greater than negative 2, x is greater than 2. So we have greater than 2 but less than 6. And that's not inclusive. So we have 2 and 6. 2 and 6. And you see it looks like this guy right here. But there's one other small factor in play that we really didn't discuss yet. So when we go to the bottom here at 2 for -1. So when we have a series, so let's say we plug in 2, what's going to happen then is we will get something like n equals 1 to infinity, 1 over n to the 1/2, and we would have -1 to the n. Because we plug in 2 minus 4 divided by 2 gives us -1 to the n. What we're going to now have is an alternating series. So even though 1 over n squared of n doesn't converge on its own, when we make it an alternating series, it can converge. So the reason that is the alternating series tests. The requirements for alternating series tests is it has to go to 0. So 1 over square root of n does go to 0. So we have n goes to 100. 1 over square root of 100 is 1/10. Okay, it's getting closer to 0. 1 over square root of infinity is still 1 over infinity, which is 0. So the series does go down to 0. So you have to think of it, all right, so normally it goes like that. But then what the alternating part does is, and this is going to be, there's supposed to be boxes because it's alternating series test, but I'm representing it, but you get the idea. What the alternating series does is it kind of does something like this. And the negatives start to cancel out the positives. And with the alternating series test then is, so if it's going towards 0 and it's alternating between positive and negative, which -1 to the n does, then it'll also converge. So what happens here then is we know that everything between 2 and 6 converges. So this one, that one, and that one. But when we use 2, we also get this -1 to the n term in there, which can then work with the 1 over square root of n. So what we're actually going to have is 2, this little bracket here, that means includes. The rounded parentheses, not include. So we want to include 2, but not everything between 2 and 6, 2, but not 6. Because when we do 6, you look back at our equation, 6 minus 4 divided by 2, that's 2, that's positive. That gives us something that would be like this top line here. But when we do the 2, we get the alternating between negative and positive. And that will converge. So the interval of convergence for this series is 2 included, 2 but not including 6. And that's how you do one radius and convergence question.